We want to write the equation of the circle in standard form and then give the center and radius of the circle. We're given the general form of a circle, which we should recognize because the coefficient of the x squared term and the coefficient of the y squared term are equal. Our goal is to write this equation in standard form, which is given here below. Once we have the equation in standard form, the center will have coordinates hk and the radius will be equal to r. So looking at the standard form of the circle, notice how we have the quantity x minus h squared and the quantity y minus k squared, which means we want both the x part and the y part of this equation to be perfect square trinomials. So we'll have to complete the square on both the x part and y part of this equation. But to do this, we want the coefficient of x squared and y squared to be 1, so our first step here is going to be to divide both sides of the equation by positive 2. Now we'll simplify this and set it up to complete the square. So this first term would be x squared, and then minus 4x, and then we're going to add a special constant here to make this a perfect square trinomial, which we'll do in the next step. And then we'll have plus y squared plus 6y, and then the same thing for the y part. We're going to add a special constant here to make this a perfect square trinomial. And then 8 divided by 2 is equal to 4, so we have plus 4. But let's go ahead and subtract 4 on both sides to move the constant to the right. So we'll have equals negative 4. Then because we're going to add two constants on the left side of the equation, we need to add the same two constants on the right to maintain the equality. So let's go ahead and leave room for those as well. And now we'll complete the square on x squared minus 4x. To do this, we'll take half of the coefficient of x and square it. So negative 4 divided by 2, that's half. Squared would be negative 2 squared, which is equal to positive 4. So we'll add 4 here and add 4 to the right as well. And then for the y part, we'll take half of the coefficient of y and square it. 6 divided by 2 squared. 6 divided by 2 is equal to 3, so we have 3 squared, which is equal to 9. So now we'll add 9 to both sides of the equation. Now we'll factor x squared minus 4x plus 4 and y squared plus 6y plus 9. These will both factor into two binomial factors, and they should be perfect square trinomials, so the two factors should be the same. So for x squared minus 4x plus 4, we have x and x. We want the factors of positive 4 that add the negative 4. That would be negative 2 and negative 2. So we have minus 2 and minus 2. Notice that negative 2 was the value we squared to obtain the constant of 4. In the next step, we'll write this as the quantity x minus 2 squared. Then for y squared plus 6y plus 9, we want the factors of positive 9 that add to positive 6, which would be positive 3 and positive 3. So we have y plus 3 and y plus 3. Again, notice how the constant 3 was the value we squared to get the 9. Notice we do have a perfect square trinomial. On the right side, we have negative 4 plus 4, that's 0, plus 9. This should be equal to 9. For the standard form of our circle, we have the quantity x minus 2 squared plus the quantity y plus 3 squared equals positive 9. So now we can find the center and the radius. Since we have the quantity x minus 2 squared, the x-coordinate is positive 2. And since we have the quantity y plus 3 squared, the y-coordinate is negative 3. Notice the signs of our coordinates are the opposite of what we see inside the parentheses. We have x minus 2, so the x-coordinate is positive 2. We have y plus 3, so the y-coordinate is negative 3. And for the radius, r squared is equal to 9. And this is a length, so we're only concerned about the positive value of r. So if we take the square root of both sides of the equation, or the principal square root, we can see r, the radius, is equal to 3 units. Now we have all the information the question asks for, but let's go ahead and graph this on the coordinate plane. Notice the center of the circle has coordinates 2, negative 3. And then for the radius, if we sketch a segment from the center to any point on the circle, let's say this segment here, we can see the radius is 3 units. Okay, hope you found this explanation helpful.